1, 0.
1, 2, 3, 4.
Hi everyone, welcome to the 6.1 to 6.3 chapter review. So attached in your notes we have some practice questions right here just as a check-in to see how we're doing. I'll go through some of the solutions and we'll see if we're on the right track. Okay, so this should be done after you've already attempted all of them, and this is more of a check or a way of being able to go back and seeing how to figure out certain individual problems. Question number 1, the reference angle right here. Okay, so we can do this without a calculator, and the reason we can is because we can say here's 0, here's pi. So right here, this would be half a pi, and if we want to have something where we want to know what's that out of 5, then we could say, well, 3 out of 5 is like 0.6 of a pi. That's a little more than half of a pi. So we actually know that we're going to be over here, just in the second quadrant. And if we drop that down to the x-axis, we could say, well, if we've traveled all the way over 3 pi over 5, and pi is equivalent to saying something with 5 pi over 5, then the gap left right here, the reference angle, would be 5 pi over 5, subtract 3 pi over 5, and that's going to give us a reference angle of 2 pi over 5. What's the reference angle of 5 radians? Okay, we need a calculator for this. Once again, here we could say, well, we have 0, we go all the way around, we get to 2 pi. Here was pi, and here's 3 pi over 2. Okay. Now, if we go 5 pi radians, sorry, not 5 pi radians, just 5 radians, we are just past the third quadrant into quadrant 4. This right here is 6.28 is a decimal. That's just 3.14 doubled. And here's 3 pi over 2. And if you put that in your calculator, you'd get something around 4.71. So if we take a look at something that's 5 radians, sorry, not 5 pi radians, just 5 radians, then this would be right here. And that would be 6.28 subtract 5. And if they went to the nearest hundredth, that's going to give us 1.28 radians. Okay, right here, we have something in quadrant 4. Okay, we've gone over 3 and down 11. And they want to know the exact value of cosine. So we need to do Pythagoras. So we do Pythagoras with the 3 and the 11, and you get 3 squared plus negative 11 all in brackets squared, and that would give you a hypotenuse eventually of root 130. And if they want to find out the value of cosine, cosine would be ka. So cosine is going to equal adjacent over hypotenuse. And because we're in quadrant 4, cosine is a positive ratio. Okay, let's move on to some more questions now. Okay, so example 4. Cosine of 60 plus cosecant of pi over 4. Let's find out each of these individually. So we can draw right here 60-degree angle here for cosine. 60 degrees, we have 1, root 3, and 2. And cosine is going to give us ka 1 over 2. Okay, so we get 1 over 2 plus, and then cosecant of pi over 4. So pi over 4 is in radians. That's a 45-degree angle. That's our 1, 1, root 2 triangle. And cosecant is the reciprocal of sine. So if sine is so, opposite over hypotenuse, this would be hypotenuse over opposite, and that would give us root 2 over 1. We get a common denominator, so you could say times this by 2, times this by 2, 1 plus 2 root 2 over 2, and that would be a good answer. And that's expressed as a single fraction right there. If we haven't seen the squared value here come in too often yet, and all that means is it's equivalent to saying we want to find out what's the value of tan 2 pi over 3 all squared. So if we can find out just what tan of 2 pi over 3 is, then we're all good. 2 pi over 3, we can figure out, you can convert that to degrees if you're still thinking in degrees. We know that a pi over 3 is 60 degrees, and we have 2 of them, so we have 120 degrees. And if you're thinking in radians, regardless, we know that we're going to be somewhere just past quadrant 1 into quadrant 2. We would have a reference angle here of either pi over 3 or 60 degrees. We can draw our special angle triangle. And we know that for tan, we have TOA, opposite, over adjacent. And if we say, what's just tan of 2 pi over 3? Tan of 2 pi over 3 is going to give us root 3 over negative 1, or just negative root 3. But then that value is being squared. So we're going to square that, and negative root 3 times negative root 3 is just going to give us positive 3. Right here, we want to know what quadrant we're in. Cosine is greater than 0. Whoops. Let's just adjust that back, sorry. Okay, cosine is greater than 0. So we have our cast right here. We might be here or here. Tan is less than 0. Tan is negative in the S and the C quadrant, so we must be in quadrant number 4. Okay, find the arc length here. So we know that arc length gives us the formula A equals R times theta. Michelson sometimes uses S equals R times theta. Same thing. If we have a diameter of 8, then that means our radius is going to be 4. So we're going to put in 4 for the radius. And then theta, remember, is always measured in radians. So if we have something that says 35 degrees, then that's going to be equivalent to not saying 35 degrees, but we could convert that to radians by doing 35 times pi over 180. And then to get our arc length, it doesn't say how to leave it. So let's leave it in exact terms, meaning we'll leave our pi in there and we'll not use a calculator for it. So if we want to reduce this to the lowest terms, you could do 4 times 35 divided by 180, and then let's reduce that into lowest terms. And if you do that, you should get something where we would have 140 over 180, which would reduce to 7 over 9 pi. So 7 pi over 9 right there. Find cosecant 2.24 to 2 decimal places. The reciprocal of cosecant is sine, and we know that sine of theta is equal to 1 over cosecant theta. We also know that means then that we could also say that cosecant theta is equal to 1 over sine of theta. So if we have cosecant of 2.24, we can just replace the theta and say cosecant of 2.24, make sure you're in radian mode on your calculator, divided by 1 over sine of 2.24. And if you put that in your calculator, I think you get 1.28 to 2 decimal places. Find the exact values. So for each of these, let's first figure out where they are around our circle. We have 3 pi over 4. You can convert that to degrees. That's 135 degrees. We have a 45 degree or a pi over 4 reference angle. And cosecant is the reciprocal of sine once again. So we have hypotenuse over opposite. And if you go hypotenuse over opposite, you just get root 2 over 1 or just root 2. So make sure it's an exact value. You're not putting this in the calculator and coming out with some sort of 1.41 decimal or anything like that. We want to see the square root of 2 as your final answer. cotangent of negative 8 pi over 3. If you're thinking in degrees, you could always convert it to degrees. If you feel pretty comfortable about how to move around in radians now, we should start to do that a little bit more. It's going to convert to negative 480 degrees. If you're thinking in radians, we've gone back a full 2 pi. That's the equivalent of saying 6 pi over 3. And then it's going back an additional 2 pi over 3. So negative 8 pi over 3 would be somewhere over here. And oops. And if you still don't feel great about that, then you could say, well, that's negative 480 degrees. So I'd go back 360, back 450 would be right here, and then 480 would be somewhere in quadrant 3 over here. So if we've gone over that, that would give us a reference angle right here of 60 degrees. Okay. And that would give us a 1, root 3 and 2 right here. Cotangent is going to be the reciprocal of tan. So if tan is opposite over adjacent, we have adjacent over opposite. So adjacent over opposite would look something like that. And we know that we're in the tan quadrant. So that means both tan and cotan would be positive right there. So we'd get 1 over root 3. Okay, and then finally here we have secant of 3 pi over 2. So 3 pi over 2, we know, well, here's pi, here's 0, back to 2 pi. And so down here is 3 pi over 2. And we have one of our quadrantal angles. And so if we have one of our quadrantal angles, then we know that, well, this is the point 0, negative 1. And if they're saying something about cosine, so we know cosine represents the x value. So if this right here is going to represent what cosine is, and this is going to represent what sine is, and we get a value of 0 for cosine. So cosine of 3 pi over 2 is equal to 0, then that means that its reciprocal, secant of 3 pi over 2, would be the reciprocal of 0. So if we flip around 0, we're getting something that would be undefined. So right here, we could say this is undefined. Okay, finally, example 10. Determine the value of secant theta if cotangent is equal to negative m, and then it just qualifies that m is greater than 0 and sine of theta is less than 0. This is a bit of a tricky question. I would begin by putting that as m over 1, so you see cotangent as being equal to some sort of a ratio, and then we should figure out what quadrant that we're in. So we draw our quadrants and we fill in our cast. And we see that, well, sine is less than 0. So sine is either going to be in quadrant 2 or quadrant 3. And it's saying the value of m is greater than 0. So that means m could be something like 1, 2, 3, any sort of positive number, but it's being times by a negative sign. Okay, so that means that cotangent is going to be equal to something that's going to be a negative value. It would be like negative 1, negative 2, negative 3. So because cotangent is negative, that means that we're either going to be in quadrant 2 or quadrant 4. Quadrant 4 satisfies both of our restrictions, so we know that we're in quadrant 4. And then from there, we could say, well, cotangent is adjacent over opposite. So adjacent is our m, and opposite is right here. There's our 1, and we know our 1 is negative, and that's how we came up with our negative m ratio. And so what we want to be able to do from this is they want to find out the value of secant. And in order to find out secant, we need to know what the hypotenuse is right here. So what we have to do is we have to do Pythagoras with m and with negative 1. So we could say m squared plus negative 1 squared equals, we don't know, c squared. M squared plus 1 equals c squared. Square root both sides. And the square root of m squared plus 1 is going to be our hypotenuse. based off of that, let's see what would end up happening. We could say then that secant would be hypotenuse over adjacent, and our hypotenuse is going to be root m squared plus 1, and our adjacent is m right there. So secant, the reciprocal of cosine, hypotenuse over adjacent, we get root m squared plus 1 over m. Okay, there you have it.